Good evening, everybody. Welcome to Turfgrass Epistemology. This is going to be a fun night. There's a really good article we're going to go over tonight, one of my favorite articles of all time. We're going to go over some video in the beginning. We're going to go over a video at the end. We're going to refer back to yesterday's article briefly, and we're going to get closed off with my favorite Mexican band at the end. So it's going to be a fun night. I hope everybody's doing well. Welcome to Turfgrass Epistemology. How do we know what we know about turfgrass science? That's what we're here to find out. How do we know? Well, we explore the literature, we explore the scientific results of various papers and so forth, and we kind of hopefully help build a model around whatever topic is going on in turfgrass science. I see there's already a lot of people here. Super TA, Chuck Benzing. I thought I saw somebody earlier who wasn't able to make it. Oh, it was Randy from Bulgaria. He was here earlier and said he couldn't make it tonight. Chuck says, I've stumped Shazam more than once. That wasn't my intent. I'll be happy to tell you the bands that I play. I'd be happy to. It doesn't bother me at all. It's not a secret or anything. Gray, Brady 419, good evening. Gardner Earth Guys, good to see you back again. Power Super Ultra Mega Triple Green, now in concentrate Ultra Super Green. Okay, only $99 plus shipping and handling. Yeah, that happens a lot with some marketing in our industry. Super Green. That was, if for those of who may not have caught the first podcast I did 2 days ago on iron. I went over a PowerPoint presentation that showed a bunch of labels. And on there, I showed a bunch of marketing bags and things like that. And they're always super green, make your grass greener, green knockout or whatever you want to call them. and most of them, in terms of liquids, do that. They do help. If it's a soluble liquid product, it will help. But if it's a granular product, we're going to learn through the next several weeks that granular products are of almost no value. And we're going to talk about that tonight. Sometimes you see a response for sure. I mean, if it's a chelated product on the right chelate, on the right soil, at the right rate, at the right time, and all those things, sometimes you can see a response from granular iron chelate, but it's usually very expensive and fleeting, and it's hit or miss. But we'll go over that. We have plenty of time. No, although the Mexican band is not, I don't know what that even means. Guy Fanes, I don't speak Spanish. The Mexican band is a sister band they're barely out of teenagers. I think the bassist might still be a teenager. But they're bringing hope back to hard rock. I'm very disappointed in the last 15, 20 years of heavy metal and hard rock. And the warning is holding true to my roots. They're giving me hope that hard rock and metal still can be good. Hard rock and good heavy metal can still be created. So they'll close us off at the end with a very appropriate titled song for tonight. Okay, that's enough on the chat. Let's go. We're going to talk today about. Well, I'm going to go back to the video I went over yesterday. I didn't really feel like I did it justice, or I didn't really cover it well. There was a video on a website or a YouTube channel called Yard Mastery that I went over yesterday, and I just kind of briefed over it. But today I want to go over it again because yesterday's article showed that this concept of making your grass double dark by adding iron in with nitrogen and the nitrogen takes it up is mostly inaccurate. And that was yesterday's article. And today's article is going to further reinforce that concept, but it's going to do it in a much more solid way. It's going to be much more defined as to what exactly is going on between nitrogen and iron, or what's the likelihood of actually seeing a response to iron being greater when you apply nitrogen than without. That's what we're going to talk about tonight in our article tonight. So I want to go back over that article from yesterday, or the video from yesterday briefly. It's only the first first minute of the video, because the rest of it is just him meandering through salesmanship and whatever he's wanting to try to do to sell his product. It's fine. But anyway, so let's talk about, we're going to show this. It's only 2 minutes long. I'm only going to show the first 30 seconds. And then I'll pause it and go through. I'll kind of walk through. I'm also going to introduce tonight the concept of fertilizer formulations, which many of you probably are very familiar with. But to make the best use or the most efficient product and the most efficient fertility program for your turfgrass, there needs to be some fundamental understanding of fertilizer formulations. And I'm going to go into that. There'll be probably several episodes where I go into it, like basic fertilizer formulations or the fundamentals of fertilizer formulation. And then I'm going to go into it in great depth, which I do about every year or two at the golf industry show. I go into, I think it's a 4-hour workshop on nothing but fertilizer formulations and how to formulate the most efficient fertilizer. I'm going to do that on my channel. It'll be some time before I do that. But today I'm going to introduce that topic a little bit. Okay. And I'm going to use this video to do it. Let's listen up.
All right, y'all. So today we're going to answer some questions that we've gotten around our double dark fertilizer. And I'm going to give you some different ways that can use it. So we've talked about this before. It's a 1600, 16% nitrogen, but it's got 6% iron. And that's really the key here.
Okay, so this fertilizer is 1600. And he's showing the tag here, the guaranteed analysis. And below the guaranteed analysis, you're going to see the derived from statement. And you can look up the Florida fertilizer label. I think actually I authored that in Florida. You can, if you Google Florida fertilizer label, it'll probably pop up. And I think my name's on that. I can't remember now. But anyway, it outlines the components of a fertilizer label. And in here, you can, not always, but many times you can reformulate what's in the bag. And why is that important? Because once we go through the next several months, maybe a year, I don't know, and we talk about all the elements, there's going to be some fundamental knowledge or understanding of what should be going into the blend, or what's the likelihood of seeing a turf response to things that are in the blend. So what's the likelihood of seeing a turf response to potassium? And whether or not you choose to spend your money on that will be up to you. But then at least you'll know the risk and the likelihood of seeing a response to it. And same thing with iron, same thing with manganese. But then we have to figure out how to formulate it, how to formulate the fertilizer. And when you look at these labels, you can reformulate it. And when you reformulate this fertilizer, you're going to see that it's an incredibly wasteful product. Okay. How do I know that? Well, one, I've formulated fertilizers for ages and ages manually, but when I want to teach you how to do it as well if you don't already know. On this, you're going to see 16% nitrogen, and then you're going to see iron, manganese, and zinc. And then down here, you're going to see derived from. Now, the majority of what's in here is nitrogen, 1600, and the majority of the raw materials in here are going to be nitrogen raw materials. So let's start with that. If we look at the polymer-coated urea on here, at the bottom it says derived from polymer-coated urea, and then it says ferrous sulfate, and then it says urea, and then biosolids, which is a big black box. I don't know exactly which one they used, but it says urea, and then ammonium sulfate. So we have, I'm going to say 3 nitrogen sources, but really 4 because biosolids is going to have some nitrogen in it too. But I'm going to sort of stash that aside for now. How do we know how much of those raw materials are in the fertilizer? What we would first want to do is look down here below the derived from. It's going to have the percent control release nitrogen. It's going to say from polymer coated urea. It's let's say 8.5%. This can slightly change based upon the manufacturer's tolerance of fines, meaning penalties. So if they say 8.5%, it might actually be 9%, but they're going to lower it. Each distributor has an ability to lower it, because if they say it's 8.5 and it comes back at a certain percentage below that, they're going to get fined. So let's say it's 100% sulfur coated urea, and down here it'll say, let's say it's a 4300, and down here it's not going to say 43% controlled from sulfur coated urea, because if they test it and it comes back as 40% rather than 43% because of some happenstance, then they're going to get fined for it. So they'll arbitrarily lower the percentage down to reduce the chances of being penalized. So I don't know exactly if it's 8.5% from polymer coated urea. It's probably 9%, and they just lowered it down slightly. So let's say it's 9%. 9% of the 16 is from polymer coated urea. That's how we start the reformulation process. 9% is from sulfur coated or polymer coated urea. When you look up here under the total nitrogen, 13.9% is from urea. So between polymer coated urea and urea, let's say 14%. 14 units of the 16 units is from urea and polymer coated urea. And the remaining nitrogen either comes from ammonium sulfate or from biosolids. Okay. It's a long, convoluted way of saying you can reformulate this if you have the knowledge. And I've done this. I have a little cheat sheet calculator that I use to reformulate these things. And what that tells me is that, roughly speaking, this fertilizer is probably around 1,100 to maybe as much as 1,200 pounds of plant food and 800 pounds of filler. So in this fertilizer, you're doing, let me get a calculator, hang on. In this fertilizer, you have, you're going to buy a ton. And you're going to buy, so you're going to buy 40, 50 pound bags. 16 of those 40 bags are nothing but wasteful filler that provide no agronomic value to you. That's my estimation based upon my best reformulation estimation. Okay. You probably don't know that, or maybe you do, because we're not required to put filler on the bag. That's not a legal requirement. I wish it was, because then the consumer would realize how much waste is in this fertilizer that's unnecessary. The same amount of plant food can be reformulated such that you can eliminate those 16 wasteful bags that you're paying $25 or $30 a bag for no reason. They're not providing you any value at all. You might not have known it, but now you know it. If you know how to reformulate this, there's 16, let's call them $20 bags that are doing you no good. Zero. So you just wasted whatever the money that is. You just wasted $320 for every ton because you're buying a fertilizer that contains a tremendous amount of filler and you didn't know it because you didn't have the knowledge to know how to reformulate this properly. Okay. We're going to get into the zinc and the manganese and all this other stuff, but just knowing how to formulate and reformulate can save yourself a ton of money if you know how to do it. Okay. And we'll go into that, but I wanted to make that clear here is that the 1600 really, if it was reformulated correctly to have no filler in it, it would be probably like a 2500 or 2800 or whatever. And then you wouldn't buy as many tons. Instead of buying 2 tons, you'd buy 11 or 12 tons, or I'm sorry, instead of buying 20 tons, you'd buy 11 or 12 tons or whatever. You see my point. You've removed all that junk and now you're dealing just with plant food alone. And then you just lower your spread rate down from 300 pounds per acre to 150 pounds per acre or whatever. And you're good to go. Okay. So we'll get into that. That's what I'm hoping to eventually get to the point where you all are able to do that on your own if you can't already. Okay, so we're going to talk about, he talked about iron, 16% nitrogen and 6% iron. Now, we talked about yesterday, this 6% here is irrelevant. It doesn't make any difference. This 6% is useless to me. What is useful is this soluble and chelated iron, really the chelated iron. So we're going to say 0.5%. And I talked to you yesterday about the 0.5% chelated iron in this fertilizer. If you applied it 300 pounds or applied it 100 or 1 pound of nitrogen per 1,000, you end up putting about 1 pound of chelated iron out per acre. And the article from yesterday also had a rate in there of 1 pound per acre of chelated iron. And I showed yesterday exactly what was likely to happen. And he's saying that, let me rewind, he's saying that applying this with nitrogen is going to get you double dark green. Okay. That's nonsense. Let's play it again.
Before, it's a 1600, 16% nitrogen, but it's got 6% iron. And that's really the key here is we have high iron and we also have a little bit of nitrogen to pull the iron in to turn the lawn nice and double dark green.
Yeah, see, that's a claim that is easy to oversee, guys. And I don't want to pretend as if I've never done it myself. I've done it myself. I'm guilty of just saying, it's in one ear, out the other. He's harmless. He's just selling fertilizer, whatever. I don't think that's in our best interests, because then the next time something really important happens, you might have the same approach and you get taken advantage. You're getting taken advantage of in this case, probably, if you're buying this and you're not aware. If you're aware of it and you buy it, then so be it. No problem. But if you're not aware of it and you're buying it, then you're being taken advantage of. And so what happens the next time when someone offers you bugs in a jug or whatever, and you use the same process of buying it, the same critical thinking process of buying it, you don't critically think your way through it, and you get taken advantage of. Okay, so that's the really the foundation of the issue is critically thinking, working your way through. Now he's made a claim: nitrogen and iron is going to suck up the iron into the turf plant and make it double dark green. Please, I know it. I don't know, it might be wishful thinking, but please don't let these little claims like this slide by, because little nonsense claims lead, and they keep hearing them over and over and over and over. And eventually they become, you begin to become convinced that it's true. Okay. It's not true. There's no evidence to indicate that this is true. And in fact, there's clear evidence to indicate that it's not true. But let's look and see what I'm talking about. So if we go back to yesterday's paper, which is right here, this was a paper on Marion Kentucky bluegrass. And here is the 1 pound of iron up here in the top. Oh, I changed the color of that. Sorry, I was doing something earlier today. Here is the 1 pound of iron that he's talking about. These lines down here are with no nitrogen, and these lines up here are with nitrogen. And so his claim is that you're going to suck up the iron with the nitrogen application and get it double dark green. But the evidence doesn't support that. And this is clear right here. Whenever we apply nitrogen with the iron, the actual influence of iron is disguised. It's masked. You don't get it double dark green. You get it green from the iron when no nitrogen is applied. When the plant is not as green, that's when you see the impact of the influence of applying iron, not when you're applying nitrogen. Okay, that's what this graph says with color. The same thing happens down here with density. You see that the density is actually, well, this isn't statistical, but it's probably biological. The density is slightly reduced from the application of iron when nitrogen's applied. I don't think that's statistical, but there is a biological reduction here for the first 5 or 6 weeks from applying iron of 1 pound per acre of chelated EDTA iron, granular EDTA. There's a little bit of a reduction in density when you apply it with nitrogen. When you apply it without nitrogen, you don't see that. So, it's not. I mean, it might be something to easily slip over, but it's not. I really don't think it is. I don't want you to think that way. I don't want you to think, he's just spouting whatever he wants to spout. It's not true. There's very little evidence to support it, and it's important that we confront this and cut this off before it grows into a bigger cancer. Okay. He's also let's go back to the video on this label, on the label that he showed. Let me back it up just a little bit so you can see the label. On this label, you see zinc and manganese and iron. Okay. This zinc here is also completely useless. There's no real value to applying zinc to turfgrass. There's very little value to applying manganese, but it can be beneficial in some cases. But here he has zinc. Let's see what happened on yesterday's paper when zinc was applied. So we go back here. When zinc was applied, let's go down to the bottom. I'll just say real quick. Zinc and the conclusions did not affect color of grass or density of sod. Nothing. Okay. The effects of zinc are over here. On this left side, the 5 and 25 pounds of treatment of zinc had no effect on the growth rate, color, or sod density of Marion Kentucky bluegrass. Root growth was stimulated by 5 pounds. The rhizome growth was strongly inhibited by 25 pounds. So the only thing that really had an influence on the rhizome growth on this particular study was excessive amounts of iron caused a toxicity, and excessive amounts of zinc resulted in a toxicity. So it's wasteful. It's not resulting in any benefit to you, that zinc in that fertilizer. Okay? It's not helping. So you're applying a fertilizer that has nitrogen and some of these other micros in it without possibly, I don't know, I'm assuming, without necessarily knowing that there could be a negative consequence to applying these other heavy metals like zinc and iron and boron and all these other things. Okay, there can be a negative consequence to applying those fertilizers that contain all this other stuff. Okay. One, the chances of seeing a beneficial response is very, very low, extremely low. And I would argue that there is probably an equal or greater likelihood that you're going to see a negative consequence from applying some of these things like zinc and boron and, high levels of iron and so forth. But clearly the claim that you're going to apply this with nitrogen and it's going to be double dark is not supported by that paper. Today's paper, that was on Kentucky bluegrass. Today's paper is a much more robust and thorough paper, specifically tailored to lawn care. Okay. This paper is an exceedingly important paper to go over. It's one of my, like I said, it's one of my favorite papers. And for whatever reason, I don't know. I just get a kick out of these old papers like this. I think back like 1988. This was published in 1988. Let's get it open here. This is Centipede response to foliar applications of iron and nitrogen, published in 1988 from an agronomy journal. So this is a top tier journal. In 88, they were doing this work. This is back before, we still had rotary dial phones, and my great grandmother still had a party line phone in 1988, and these guys are out here doing all this work. It's amazing. And they were doing it with instruments and equipment back then that are really antiquated compared to what we use today. And they were still getting things done. It was fantastic. So in this study, you're going to see 3, maybe 4, but I know for sure 3 separate studies. Okay. They were looking at if you're familiar with centipede grass, you know the challenges with growing centipede grass. And they were looking at trying to figure out a way to, keep it greener without causing harm to it. You go out there with centipede grass, you start dumping on the nitrogen and dumping all these elements. It's a really good way to kill it. So, but occasionally centipede grass needs a little more color, and they were trying to figure that out. So they did a little bit of iron and nitrogen work at different rates, at different temperatures, and so forth. And that's what we're going to go over today in this paper. And we're going to look at specifically on this paper in fact, there's 26 ratings. I had to make a note of 26 ratings in this paper that look specifically at the interaction between nitrogen and iron and whether or not the iron response was ever different when it was applied with nitrogen. So, that's why I get a kick out of this, because this stuff exists. You just got to know how to go find it and then know how to understand it, I guess. But when you see claims like that just come out of thin air, it's just critical that we don't let it slide any longer. Our industry is already so badly polluted by nonsense that at some point we got to draw the line. And even if it's something as simple as a little sort of innocuous little claim like that, those little claims build and build and build and build before you know it's just an avalanche of nonsense, and you don't know what's true and what's not because we didn't cut it off at the beginning. Okay, so let's get it going. Centipede grass response to foliar applications of iron and nitrogen by Bob Carrow, Johnson, and Landry in 1988. Now, if you don't know who Bob Carrow is as well established a legend in the turfgrass industry as there ever will be. I don't know. I guess Dr. Beard might be more of a, larger figure than Bob Carrow, I suppose, but there's not many bigger than Bob Carrow. And this paper, to me, is immensely important. Okay, so we're going to read a little bit for those people who might not know about centipede grass, or those people who might be new to the channel. These articles that I go over, you can be a member of the ASA, the Agronomy Society of America, Crop Science Society of America, or the Soil Science Society of America, and download these. If you're a member of those, you can download these for free. Otherwise, you can go download at least the abstract for free. And this is a large portion of my articles that I go over in the Tri-Societies. So feel free to go over and check out the Tri-Societies and consider being a member if you're not already a member. I think I have to re-up mine next month. Actually, I'll have to do it before Christmas, I think. And I'm going to probably do that online. I think if I have the time to do it, to show you how to do it. And I think you can do it between $100 and $200 a year. I'm not sure. It used to be $400 or $500 a year. I think now they've adjusted it to where I can get the publications for less. I can get all the publications now for one fee rather than getting them individually. So I think it's less money for me now. I'll figure that out. But please consider that if you haven't already done it. All right. Anything interesting in the chat before I start off on this thing? You guys are so nice to me. Woody 865 says I enjoy listening to you. Well, okay. Thank you very much. Ulysses Serpa, I have reduced my lawn plan in 2024 by a full pound of nitrogen due to listening to your research papers. You know, I'll try to get through this without getting too sentimental here, but when we're in academia, one of the most difficult things to do for professors going up for tenure and promotion is to document their impact on their stakeholders. How much money have you saved their stakeholders? How much change and behavior have you been responsible for in your stakeholders? It is a massive big black box. And one thing that, at least when I was in academia, one thing that was never considered to be a valid measurement was social media or YouTube. And on here, I can count, I know for sure one person has joined the ASA, I believe as a result of my podcasts. A number of people who have participated in the online consultation service I provide through Calendly.com. A number of people have adjusted their management practices through that service I provide. And on these comments, you all have you all make a point, somebody make a point of saying, I've reduced my nitrogen because of listening to you. That is direct impact that when I was a professor, I couldn't really measure because I wasn't spending my time doing stuff like this. I was spending my time on grants and grad students and committees and things like that. So I guess I'm saying all that to say that I think academia might have to reconsider their formula or their model of how to measure the value or the impact of professors in the next, now. And, I think professors are so busy doing other things. The industry has passed them by oftentimes because they're so stuck in a certain way of qualifying for tenure and promotion. And it's not on YouTube. It's not seeing the impact like this. I can measure impact much more precisely this way than I could in the past. Anyway, thank you for saying that. It's very, very, very nice of you to say that. Mitch Bird says the lawn care nut equals thrower down. Though that's that guy's name. Okay, see, I thought that was, when I saw him, it said Yard Mastery, and I was like, I thought he was on a different channel. And it said, okay, now I'm connecting the dots. I'm sorry, I'm a little behind the times. As I said, I spent my time last decade or two in a lab or grad students or doing other things, and I didn't really keep up to date with all this stuff. Yard Mastery sells that 45-pound bag for $75. Jeremy Bosch says that? That's $75. Holy cow. $75. Oh my goodness. I didn't know that. Let's just assume it's 50 pounds. That's $3,000 a ton. You can buy 100% polymer-coated urea for less than that. That can't be right. $75. Is that right, guys? Jeremy Bosch says $75 a bag for a 45-pound bag. Is that right? Am I doing the math right? My goodness. Well, keep watching this channel because you're going to learn real quick. You don't need to spend that much money on stuff. We're going to get into nitrogen sources. We're going to get into the cost of nitrogen sources and the longevity and the turf response to nitrogen sources, all that stuff real soon. And you don't need to spend $75 a bag to have an acceptable turf grass. That's crazy. All right. Ulysses, okay, granular only. My lawn is 15,000 square feet, so foliar is not ideal. Turf type tall fescue in Connecticut. Oh, so Ulysses, are you asking a question about, you can only do granulars, and your question is, let me come back to me here. I guess I'm answering some questions right now. So your question, or is that a question, Ulysses Serpa, is like you can only do granular only, and you're curious as to what you can use as a granular? I have turf type tall fescue in my lawn here in Kentucky, but if you are strictly granular only, when you're dealing with 15,000 square feet, so a third of an acre or whatever that is, and you don't want to walk spray it. I have 8,000 square feet, and I do walk spray mine occasionally, but I have a 2-meter boom that I can do it in 2 or 3 tankfuls. But I don't blame you for not wanting to spray that. But if you can't spray iron, I get this question a lot, actually, not on this channel so far, but I have gotten this a lot in the past. I understand what you're saying, Dr. Shaddix, but I'm not going to spray out foliar iron. I can't do it. I don't have the time. I don't have the equipment. I don't have whatever. I can only spread it. So if you can only spread it, then you're out of luck, honestly. You can spread chelated iron, as I'm going to show you today. Well, they sprayed it today, but on the previous article, they spread it at 1 pound and 5 pounds. But that is an exceedingly expensive and inefficient means to get you a little bit more color. So iron is not going to cure a nitrogen deficiency, and nitrogen is not going to cure an iron deficiency. So if you're only spreading fertilizer and you have no option of spraying fertilizer, then you really don't have any viable option to apply iron unless you want to fork over the cash to put down granular iron chelates. But when I'm going to get into this, it's going to be another week or two, but EDTA, it is a chelate, but it is completely useless on soil pHs of greater than 7.0. There's no point in doing it. So when I say you can spread it, there still is really no value to it if your pH is above 7 if you're going to spread EDTA. And EDDHA and DTPA, I don't even think they make granular forms of that. So your only option is EDTA. So if your pH is, say, 5 or 6, then you might be able to see something from that. But if your pH is greater than 7, it'll oxidize out. Almost all that iron will be gone in one day. So unfortunately, for those of us who only spread fertilizer, and when you have a neutral or alkaline pH soil, then there really is no viable iron option for you. Okay. Okay, so Gardner, the last couple of years, the liquid iron urea from Lesco would jam the Z-Max straight up rust in a jug. I'm going to show you a video at the very end, Gardner Earth Guy, that might be right up your alley. Exactly that topic. The very, very end. Oh, okay. Sorry, listen. I just did. I'm trying to catch up with all this stuff, and so that 1600 is $70. It's $80. Wow, unbelievable. Well, good for him. I mean, he's a small business. You can make money however you want to make money, and I can teach you and educate you, and you can make it an educated decision. How about that? So there's not a lot of money in education. There's a lot of money in selling expensive fertilizer with a bunch of filler in it, I guess. So anyway, all right, here we go. So I'm going to read through this. I know a lot of people already know Centipedegrass and all these other things, but I'm going to read through it for those people who might be listening for the first time. Trying to kind of give you an idea of the basic situation that these authors were working with. Common centipede grass is a popular lawn grass in the coastal plains area of the warm, humid part of the United States. It has a lighter green color than most grasses and easily exhibits iron deficiency symptoms. Shoot density can be maintained on centipede grass with annual applications of nitrogen at 1 to 2 pounds per 1,000 square feet, but often without an acceptable green color. This is a problem for lawn care operators since increasing the nitrogen level can lead to centipede grass decline. One approach is foliar applications of iron in conjunction with nitrogen. So what he's saying is centipede grass is a little less green than some other grasses. You need to apply a little bit of nitrogen to get that color. But if you apply a lot of nitrogen to centipede grass, you all are probably very familiar with what happens. You get a phone call and you have to go resod the lawn because you put out your technician doubled it up or tripled it up and killed the lawn. You know, you put out 2 or 3 pounds of nitrogen on centipede grass, it's a good way to kill it. So you want it a little greener, but you can't give it a lot of nitrogen, centipede grass. So the idea is, well, some lawn care companies will put out a little iron to get it a little bit greener. So that this was the situation they were dealing with back then. The purpose of this research was to determine the influence of iron carrier on turfgrass quality and color, and to determine the effects of iron and nitrogen applied alone and in combination, okay, and in combination, just like the video we watched, and there are different rates of applications on phytotoxicity, quality, and color. So this is exactly right up the alley of apply iron with nitrogen. Nitrogen is going to take it up into the plant and turn it double dark. That's what this says right here, in combination. So we're going to see what happens when you apply these in combination with each other or on their own. Gotta love these researchers. They could foresee this nonsense being published 40 years ago. Research was conducted on 10-year-old stand of common centipede grass on Cecil sandy loam with a 1% organic matter, 69% sand, but I'm not going to go through that. Iron content of the A horizon. I'm not even going to go through this because I'm not sure exactly how they measured this. 1 point iron. They talked about the A horizon of the soil, the B horizons of the soil. This is probably too much soil-related stuff that you guys even care about. The experimental site was at the Georgia Experiment Station in Griffin, Georgia. Okay, so we're in Georgia. The soil test results using the procedures of the University of Georgia Soil Testing Lab were pH of 5.5, and the potassium was at 170 kilograms per, so that would 170 kilograms per hectare, and then the phosphorus was 90 kilograms per hectare. So this was roughly, 80-ish parts per million potassium and 40-ish, 45 parts per million phosphorus. And they say that was high on both of them, and I would agree with that. I don't know what the extractant was that they used back then. It's probably Malic 1, but they say that the potassium and phosphorus in the soil were high. At least they weren't deficient. No additional okay, so all the studies, grass was mowed at a little over an inch. No additional nitrogen was applied beyond that listed as a treatment. Urea was the nitrogen source in all studies. All nitrogen and iron treatments were applied as solutions with a CO2 backpack sprayer. Now, I showed that article yesterday for a reason, because it used granular iron EDTA. And almost, I'm going to say 95% of the iron studies that you're going to see in the literature, they're almost all going to be applying iron as a foliar application, a liquid application. And some of the articles that I'll go over, it'll state in there, due to the lack of response from granular iron, iron was applied as a foliar, or was applied to the leaves or whatever. So, now I'm going to show some at the end where I did use some granular iron. But the purpose was to show that granular iron, and there's a difference between that and foliar applied iron. But many cases, you're not going to, I guess what I'm saying, you're not going to find a lot of stuff in the literature on granular iron applied to turfgrass because they know it doesn't work, to be frank, unless it's chelated with EDTA and applied at the right rate and the right soil and all these things. Okay. 3 iron carriers were chosen for the study. Iron sulfate. Notice, and this is just a point of just reflection on the previous, on my PowerPoint presentation. Remember I showed on the PowerPoint presentation, there was a derived from statement, it said iron sulfate. And then on the very next label, it said iron sulfate heptahydrate. It kind of makes it sound like super scientific. Iron sulfate heptahydrate. Iron sulfate has to come with 7 waters. And that's what this is. Analytical grade reagent, iron sulfate 7H2O. That's heptahydrate. So don't get confused and think you're buying something special because it says iron sulfate heptahydrate. It's just iron sulfate. Anyway, that was from the other day. Ferrous ammonium sulfate. So those of you who might not know, you can actually buy a product that's a molecule of ammonium sulfate with iron in it. It's called ferrous ammonium sulfate. And ammonium, and then an analytical grade reagent, iron. Oh, that's what that was. Ferrous sulfate. And the sequestrine 330 iron chelate. This was I think this was DTP. Oh, here it is. Yeah, diethylene triamine pentacetic acid. So that was iron DTPA. So we have iron sulfate. We have iron chelate, and we have ferrous ammonium sulfate in one of the studies. We're going to look at 2 other studies. And this is the next study. And that was in the, they don't identify the name of that study. And the next study they identify is the August 1985 study. And the August 19, I don't know if I'm going to go into all the details on how they did it, but basically they had 2 other studies that they looked at. And they had different rates and different things they were looking at. But almost all of them, they looked at quality and color and all these things. Let me go through. So here's a June 1986 study and a July 1986 study and so forth. I don't know if you guys care to know about every single thing that happened in the studies, but they just used various rates. Here's a sequestrine 330 again. Here's the ferrous sulfate again. They use various rates there. Here's the sequestrine 330 again. I'm going to go through all these tables and graphs, so don't worry too much about And if you want to go through it, you can go back and pull it up. Here's the measurement statistics. Just know they did 3 or 4 different studies, and they did it on various iron rates and nitrogen rates. And they generally used iron sulfate, ferrous ammonium sulfate, or DTPA, or this iron sequestrine 330. The analytics the measurements that they took was visual quality ratings on a 1 to 9 scale. They did color ratings on a 1 to 9 scale. They also measured the iron content of dried clippings in one of the studies, and they did it with a proper analysis, the analytical method. Okay. Now, let's get into the results. This is the fun stuff. I don't know how to express my just pleasure in reading stuff like this, because you can talk about all these claims, and you can talk about your opinions, and you can talk about, well, I saw this, or I know I bought his products and I know it works, da 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 da. I don't really care about any of that stuff beyond its value as an observation in the scientific method. It's an observation. You observed this, whatever. To me, it's valuable in terms of an observation. That's what initiates the scientific process. But these are results. How are you going to argue it? How are you going to argue? How are you going to come in here and argue? Well, I saw it. I know that's what they found, but I saw that. Yeah, I didn't. That's not what happened here. Knock it off. It's fantastic. Okay, here we go. So the results. All 3 iron carriers, so we're talking about sulfate iron, ferrous ammonium sulfate, and sequestrine. All 3 iron carriers caused at least some phytotoxicity, with the chelate exhibiting the least phytotoxicity. The phytotoxicity from the chelate was not particularly objectionable, since the phytotoxicity rating of up to 3 was up to 3. The turf had a darker green appearance. Both ferrous sulfate and ferrous ammonium sulfate caused substantial blackening, particularly when applied with 2 pounds of nitrogen. No, wait, no, that's not. That's not 2 pounds. That's a tenth of a pound. Or no, that's a quarter. Or well, let me get that right. I thought that was in grams per meter squared. That was in 9.8 divided by. Yeah, so that's 0.2 pounds of nitrogen. This is Centipedegrass, so they're going at a low rate of nitrogen. Nitrogen did not influence the phytotoxicity rating under the chelate. By 11 days, initial phytotoxicity response had been masked by sufficient growth to produce new green tissue, while significant visual quality and color responses were observed due to the iron. Contrast revealed that no differences occurred between the chelate, the iron sulfate, and the ferrous ammonium sulfate, but all 3 carriers improved quality and color compared to the check, even at 68 days. Okay, so this is the first one. This is the first study here, and you can look through this. Okay, this is the first day, table 2. But here's what I want to show. Here we go. This is going to be golden if I can get this on here. I don't think I can get it all on here. I can't get it all on here. Dang it. Let me see if I can try it one more time. I can't get it all on here, guys. I'll have to zoom out. So you just have to bear with me here if you can read that. I'm going to explain it for those listening. Okay, so when you see tables like this, oftentimes you'll have A's and B's and all these things by it, and you'll see differences or whatever. Those are important. Don't get me wrong, those are important. And I don't expect everybody to understand how to read stuff like this. It's not, this is 99% of the people aren't even going to bother know how to go find this stuff, much less understand how to read through the statistics. Okay, it's not really your job. Let the scientists do the science. But for me, I'm going to explain this so it makes, hopefully I do it in a way that makes sense. Here's the visual quality, okay? 11 days, DAT is days after treatment. 11, 21, 42, and 68 days. And they did the same thing with color. So visual quality and visual color. And you'll have the no iron and no nitrogen. No iron and 0.2 pounds of nitrogen and so forth, okay? And then they have the chelate and the ferrous ammonium sulfate and so forth, blah, blah, blah. Don't worry about the CV right now. This is irrelevant to our purposes tonight. Down here at the bottom, it says statistical significance. And all this can look like a bunch of jibber jabber and just sort of jargon that doesn't, it just looks like Greek almost if you don't know how to read it. But this is where we find the meat and potatoes of the paper, okay? Specifically as it relates back to the claim made in the video. So we're going to see 5.9 and 6.2 and all these visual quality ratings from the 11 days after treatment. And down here, when it says iron carrier, if it's statistically significant, it means there was an influence of the iron carrier. Iron carriers resulted in some influence. It might be up or down, but it did influence it. The next one is the nitrogen rate. The nitrogen rate is influenced as well. Okay. But I put these in red rectangles because it wouldn't let me highlight them. This paper's so old, I think the format doesn't let me highlight them. But the influence of iron with the interaction of nitrogen is here. So in other words, how did iron react under one nitrogen rate compared to the other nitrogen rate? So how did it react with no nitrogen, and how did the iron react with 0.2 pounds of nitrogen? And you see NS across the board, non-significant. So what does that mean in layman's terms? What that means is that the influence of iron was the same whether you applied nitrogen or whether you did not apply nitrogen. Okay. And we know from the first row here that iron did have an effect. You see here in every column except one, iron had a significant effect. So iron was influencing the turfgrass the same way whether you applied no nitrogen or whether you applied a lot of nitrogen or 0.2 pounds of nitrogen. So the idea that you're going to apply nitrogen with iron and it's going to make it double dark green, according to table 2, is complete nonsense. There's no evidence to support that claim according to these data. That was just one study. Let's go to the next one. The next study. To further define the relationship of iron carrier, iron rate, and N rate, a second study was initiated. The 0.2 pounds of nitrogen was chosen since some lawn care operators, see, they're showing you guys some love, the lawn care operators some love, would use this rate in combination with iron for rapid greening, while the 0.8 pounds of nitrogen would be the maximum rate normally applied during summer months for liquid applications. This is for Centipedegrass, don't forget. Even at 0.2 pounds of nitrogen, some phytotoxicity appeared, but the turf was still acceptable. Nitrogen, ferrous sulfate, and the chelate caused phytotoxicity in a linear, I don't know if I'm going to talk about that linear stuff. Combining iron and nitrogen caused a greater degree of injury than did either when applied alone, as illustrated by the significant iron rate times N rate interaction. So combining iron with the nitrogen caused a greater degree of injury than if you just applied them individually. With 0 or 0.2 pounds of nitrogen, the highest acceptable iron rate before going above a 3 on the toxicity scale was 2 kilograms of iron per hectare, which would be 1 pound per acre? Is that 1 pound per? Yeah, that'd be 1 pound per acre for iron sulfate and for chelate. So we're going to get down to the interaction things here in just a second. Iron carrier effects on visual quality and color were significant, but only between the check and iron sulfate and the chelate, not between iron sulfate and the chelate directly. So it was between nothing and applying something. But the difference between iron sulfate and iron chelate was not measured. And that's going to become important in the video I haven't shown yet. Okay, the video I haven't shown yet is a little bit involved with that. So, and that's what you're going to find when you get to my papers at the very end of whatever weeks I get to it, whatever. I did 2 or 3 studies, and the results of those studies showed that iron sulfate compared to an iron chelate applied to the foliage, there was no difference between the two colors or qualities. They resulted in the same increase in quality. And that's what he's stating right here. But only between the check and the iron, not between the two sources of iron, okay? One of them being a chelate. The major treatments that enhanced visual quality and color were nitrogen and the rate of iron. Initially, combining iron and nitrogen had a negative effect on phytotoxicity. But once the grass recovered, the best quality and color occurred with a combination of 1.5 pounds of iron and 0.8 pounds of nitrogen. Okay? Since long, so that was on table 3. Let's look at table 3. So table 3, and this is a much larger table for those listening, but we have the treatments, the iron carriers, the iron rates, the nitrogen rates, and all this stuff, visual quality and color and all these things. I'm not going to go through this whole table because there's a lot of data on here. But for those watching, those listening, I want to go down to the interactions, the statistical significant table down below. Okay, so here's iron carrier, and we see across the board, we see visual quality be influenced by the iron carrier, except on the at 4 weeks. Five weeks out? 5 weeks out, there was no influence on quality, and 5 weeks out, there was no influence on color. But there was a significant influence by iron on every other week. When you go to the interaction of iron with nitrogen, okay, let me make sure I'm doing this right so I don't screw it up. Yeah, nitrogen. You see no influence 2 days after, no influence 5 days after. You see one influence at 9 days after. Nothing. So what this is saying, just like the first table, was that iron is having an effect, but when you apply it with nitrogen, the effect doesn't change. That's what this is saying. There is no difference in the response of iron whether you include it with nitrogen or not. That's what this is saying right here, guys. All these NSs, all these interactions are saying that. That's on the second study. Let's go to the third study. Since lawn care companies often are confronted with treating Centipedegrass, a warm season species, during the hot summer months, we initiated a study on a hot day. The iron rates were lower than those used in the June 1986 investigation, while the N rates were an intermediate. So they're doing it on a hot day when the phytotoxicity might actually be worse. When applied alone, nitrogen caused phytotoxicity at 12 so this would be at a quarter pound and a half a pound of nitrogen. It caused some phytotoxicity on Centipedegrass. But an acceptable level of phytotoxicity occurred only, an unacceptable level occurred only at the half pound rate. So there was some phyto, but it wasn't really that severe except for when you applied a half pound of N. You can read through the rest of this. I'm going to skip through it. And what I highlighted in red was this. There was no difference between the iron sulfate and the chelate in terms of phytotoxicity. The significant iron rate times N rate interaction demonstrates that N, nitrogen, plus iron caused more injury than either alone. So that's another study. So when you're applying them together, you're causing more problems, and you're not resulting in any better responses. Let's go to table 4. Surely table 4 will be different, right, than the first two studies. Let's look at that. Over here on table 4, Centipedegrass response to iron carriers, iron rates, and nitrogen rates on July 30th of 1986. And we have a similar table before. We have the treatments, the iron rates, the nitrogen rates, and the visual quality. I'm going to be looking at visual quality here, okay? And we see iron carrier, significant response, significant response. And then we have 3 non-significant responses in the middle of the treatment, the 2 weeks out. And then we have a significant at the end. So we have 6 rating dates, and 3 of them there was a beneficial response. 3 of them there was no significant response. Let's look at the iron times nitrogen rate. We have non-significant. They're non-significant. So when there was an effect of iron, when there was an influence of the iron carrier, it was the same whether you applied this was a quarter pound of nitrogen or a half a pound of nitrogen. The influence of iron was the same, one way or the other. There was no significant interaction between those two. That's the third study. Surely the fourth study will be different. You know, where is that? Did I miss it here? Where did I go? Initially what did I do? Did I skip by it? Oh, let me just skip. Oh, I was down here. How did I miss that? Nitrogen rate and decreasing quality, but provided beneficial effects by later date. Oh, let me just keep going. I don't know where I messed up there. I skipped something. Between 20 and 22 days after treatment, chlorophyll, iron content, and clipping yields measurements were taken. Nitrogen applied alone reduced chlorophyll concentration slightly. The low iron rate plus nitrogen tended to reduce chlorophyll content except at the high N rate plus the chelated iron. You're going to see in a future paper, a little bit tonight, but in a future paper, they're going to show the correlation between pH and iron solubility. They're going to call it the correlation between, it might be in this one, I don't remember. Oh, it is right here in red. There's another paper as well. People have this concept that the solubility of iron or the availability of iron will be best determined by looking at the soil pH. There is very little correlation between soil pH and soluble iron until you get way low, like 4, because there's not much soluble iron at all. When you're 5, 6, 7, 8, and 9s, there's nothing. Basically, and practically speaking, there's no soluble iron. And I'm going to show a paper. I don't. Well, let me. When that is. Oh yeah, it's going to be a while before I get to that paper. But there's a paper that clearly shows, well, at least in that study that they did it in, that the relationship between pH and soluble iron, or pH in chlorophyll or whatever, when they're applying iron, there was no relationship. Okay, we're going to get to that. And this one talks about it a little bit. Significant treatment effects on clipping yields and iron content were not observed at 22 days after sampling. However, the coefficient of variability, don't worry about the CV. Okay, here we go. Correlation coefficients were calculated for the 20 to 22 days after treatment relationships between iron content and chlorophyll. Also, iron content and color. Also, chlorophyll content and color. So there's an idea, there's oftentimes some marketing saying, well, iron's good because it increases photosynthesis and increases chlorophyll and it increases all these other things. It increases greenness and all these other things, which it was true in the plant. Like I said the other day, I could not care less when I'm buying a product. I could not care less what the element does in the plant. That's a straw man argument. I want to know what the applied element is going to do in my plant. You're running a business. You're paying for this stuff. Okay. I can talk about all the elements in the plant until I'm blue in the face. It's not going to give me a lick of confidence as to what that applied element that I just bought and put on my lawn or put on my customer's lawn, what is that going to do? There is a difference between these two. And here you're going to look. They looked at the relationship between these, and it says iron content and chlorophyll, iron content and color, chlorophyll content and color. None of these were significant at the alpha equals 0.05 at the 5% confidence level. The highest correlation was 35 for chlorophyll and color. And I'm not going to go through the regression, but you can go through regression if you want to. So the best correlation there was a 35. So in other words, that accounted for 35% of the error, basically, is what they're saying. The relationship between chlorophyll and color was they only accounted for 35% of the variability, basically, in the correlation. So there was no correlation. There was no correlation found between iron content in the plant and chlorophyll, or iron content in the plant and color, or chlorophyll content in the plant and color. There was no correlation. We're going to see that again in a future paper. Okay. So don't be overly confident and overly convinced to use these products if you're using them to increase the chlorophyll or increase the color of the plant or increase the whatever in the plant. Because I'll probably show an article or two that does show there's some relationship occasionally, but oftentimes there's not. Okay, especially when you're spraying iron. And this is part of why I'm slowly, over time, becoming more and more convinced that the iron we're spraying out is not going into the leaf surface. It's not penetrating the leaf. It's being stained. It's staining the top of the leaf surface, which is giving it a darker color. And that's fine. I'm not saying there's anything bad with that. I mean, you want a darker grass, you want a greener grass, I don't know if you really care how it occurs. But I think it's just staining the leaf surface, because when you look inside the leaf at the chlorophyll content, or you look at the iron content and you start to compare these, and there's not any relationship. We're not seeing that iron we applied result in more chlorophyll, basically, is what this is saying. That's the easy way to say it. This used paper right here, 1984, is an immensely important paper, and I will go over that in detail. But in the discussion here, it says Use 1984 reported that the sequestrine 330 provided somewhat longer-term color enhancement than did iron sulfate on Kentucky bluegrass. In our studies on Centipedegrass, we did not observe any difference in iron carrier on visual quality or color responses, either in magnitude of response or duration. So they didn't see any difference in the carrier. I didn't see any difference in my papers, and I'm going to show those at the end. In the August 1985 study, all iron carriers provided a positive greening effect for up to 68 days. For the earlier summer application in June, the color enhancement dissipated at 35 days, while iron applied in the midsummer of 1986 showed good color improvement for 22 days, but none by 66 days. Since the lawn care industry's primary use for iron is for color enhancement, it appears that any of the iron carriers in this study would provide better color, but the duration may differ with seasons of applications. And I would say for the most part, that summarizes the model of iron and turfgrass right there, that statement. There really isn't much difference between the iron carriers when they're applied to the leaf surface as a liquid, as long as they're soluble. As long as they're soluble, there really isn't much difference. And the longevity of response will vary based upon the time of year and the turfgrass and the growth habit and all these things. It will vary slightly. He had it from 68 days down to 22 days, depending on when they applied it. But the carrier was of less importance. Okay. The least expensive option is going to be spray grade iron sulfate. So you can buy all these glucoheptanates and all these EDTAs and all these DTPAs and all these DDDHAs and all these other chelates if you want to. I'm not saying that you will have a response to them. There's very little doubt in my mind that you're going to see a positive response to all those forms. My question is, well, why would you spend 10 times the amount of money on this soluble iron when I can just buy soluble iron or spray grade iron sulfate and get the same response for a fraction of the price? That's been my take on iron for many years. Continuing in the discussion, when visual quality of color ratings were taken at 2 weeks or more after treatment, the highest iron rate always gave the best ratings. However, the controlling factor that determines which iron rate should be used for a lawn application is the initial phytotoxicity and not the long-term benefits. Phytotoxicity at a particular rate of iron was affected by N level and apparently the air temperatures on the day of application, so the heat and the initial phyto. So I don't think this is anything new to you guys. When you go out and apply foliar iron, it's not necessarily the longevity of the response that you're concerned about. You're probably more concerned about the initial blackening of it. So we need to know what that is. With temperatures on the date of treatment ranging from 21 to 33 degrees centigrade, 1 pound of iron per acre could be used in conjunction with up to 0.2 pounds of nitrogen without objectionable phytotoxicity. When the nitrogen rate was increased to 0.8 pounds, somewhat less than 1 kilo or half a pound of iron was the greatest iron rate. So in other words, they had to adjust the iron rate down or they're going to burn it. I think that pretty much wraps it up. That's pretty much wraps it up. Okay, so I'm going to summarize this whole thing basically. Now, if you go back through all these tables, the claim at the beginning of the video, or the video we showed, was double dark green because we're applying iron with nitrogen, and nitrogen is going to take up the iron and we're going to turn things double dark green. Let's just look at everything. Let's just look at it all. Go back to the beginning and we're going to count the number of ratings they did. We're going to look at visual quality ratings or color. They did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. My voice is going, guys. I've been a little sick the last couple of days. They did 26 ratings. Of those 26, how many times did you see a response to iron? Of those 26, okay, let's go back and count them. Of those 26, we saw 1. This is quality or color. It can be both. So I'm counting quality and color. So we had 26 total ratings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19. We had 19. We had 19 responses. Of those 26 ratings, we had 19 that responded to iron. How many of those 26 ratings was there a difference in the response based upon the amount of nitrogen that we applied? In other words, how many occasions would have supported the claim that there would actually be a difference based upon the amount of nitrogen that you're applying? Let's count them. So we're looking on this column now, and we're looking for stars. There's one right here. 1, nothing else, nothing else. 1 here, that's 2, nothing else, and nothing else. So 2 out of 26 ratings, iron responded differently based upon the nitrogen that was applied. 2 out of 26. And 19 out of 26, there was an effect of iron. So in other words, the chances of you seeing any difference in the iron response based upon applying nitrogen or taking it up and making it double dark green are extremely low. You're not going to see it, basically. Okay. So we have one paper yesterday, I think it was yesterday, that, was basically saying the same thing. You're not going to see any, the nitrogen when you apply it. That's where you're going to see the response from. You're not going to see a response from iron whenever you're applying a lot of nitrogen, because the nitrogen is going to mask it. That was from yesterday. And here today, we're seeing 26 ratings. Only 2 saw a difference when nitrogen was applied. The other 24, there was nothing. Okay, so that's, it's not just one paper. There's multiple papers that are showing this. So please don't be fooled by these poor, horrible claims and marketing schemes is what they are. Okay. I'm going to show one video at the end. Now, I actually kind of like this video, but the reason I'm showing it is because the article that we went over just now is going to be very consistent with the articles that I'll go over at the end when it talked about the differences between carriers, the differences between iron carriers. There's very little. They didn't find anything in this study that would convince them that there would be a difference in terms of response between iron sulfate and iron chelate. They didn't see any evidence in this. You'll see later, I didn't see any evidence either in the papers that I published. So the response you get from foliar iron sulfate was the same as from foliar iron chelate. And I've always contended, for many years I've contended, that there really isn't any value to iron chelates because, one, once it hits the soil, it's going to oxidize pretty quickly anyway. And you're going to have to pay a lot of money. It seems like a very, very expensive way to do it is to do it through the soil. I mean, you could, but I don't think that's really an effective way to do it. And when you do apply it to the leaf surface, you can get the same response from applying just iron sulfate. It'd be less expensive. However, there can be a benefit to using iron chelates in the manufacturing of these materials. Before you get it out on the grass, the difference in the jug, the chelates can potentially have an effect, have a beneficial value to you when you're buying it. And I don't know how many people do sprays. I don't do that many, but I do some. And I only have 4 nozzles on my boom. Okay. I have a 2-meter boom that has 4 nozzles on it. And I will do almost anything to prevent those things from getting clogged up, because I don't want to sit and spend an hour and a half changing up my damn filters or cleaning them out and spraying them out because something got salted out or something got gummed up and it went through my dang boom and got caught in my filters. I got to stop and pull them out and change them. I'll do almost anything to prevent that. And I only have 4. Okay. So the point is, if there's a benefit in the manufacturing of these materials by including a chelate that makes it clean and clear and it gets it through those screens more consistently than without, then I might be willing to pay for that. And so might you. Now, I don't think you're going to see much of a difference in the turfgrass response. Okay, the turfgrass response is probably going to be consistent and similar to just spray grade iron sulfate. But the logistics of getting it out, they might be of value to you. The chelates, and I'm going to show a video right here that kind of shows that a little bit. Okay, so I don't want to poo-poo all over chelates because there's still, there can be benefits and value to them. Let me pull this video up, and then I'll go back to your comments. Okay, I'm going to read through the comments before I go tonight, guys. So, and don't forget my favorite Mexican band's coming on at the end. But I'll go through your comments and address as many as I can before I go. So I'll try my best to read them all. Okay, so this is from a YouTube channel called Bermuda Grass Central. The title is The Best Liquid Iron for Lawns. How do I get a greener lawn? Now, this is a rather long video. I'm going to show the intro, and then I'm going to skip to certain timestamps because I just want to show the products. He does a good job of showing actually what the products look like in the jug. And I think that can maybe show my point when it comes to the manufacturing, the value of a chelate. Well, I'm not a manufacturer, but the potential value of a chelate in the actual manufacturing of these liquids. Okay, let's listen to the first minute or two, and then I'll skip ahead.
Okay, Yard Fanatics, you're tuned into Bermuda Grass Central with BYD. Now, you see the greenness, all right? And that section back there is an $8 iron product. I think it was $9. $9 iron product. And let me show you a $30 liquid iron product. Fanatics, and as you feast your eyes on the $30 liquid iron product, that product was called Fertilizer. All right, the other product was Sunnyland liquid iron.
Okay, so I can't raise the audio any louder than it is. I don't have the knowledge of how to do that. I apologize. That's as loud as I can make it. But he's showing a liquid iron from Sunnyland and a chelated liquid iron from Fertilizer. And he's going to go out and through the video, he applies them and he looks at the differences and so forth. And if I don't want to misquote this gentleman, but if my recollection is he prefers the chelated iron over the liquid iron. Now, if you look at the label on the Sunnyland, it is iron sulfate. And the label on this chelated liquid iron, I can't remember what it was, but it was a chelated iron. Okay, so let's skip ahead to 7 minutes. And what I'm going to show you is what these products actually look like in the jug. Because I can tell you right now, just by looking at the liquid iron on the left, I would not put that through my spray rig because I don't want to spend 2 hours. It might go through my screens. It might. I don't want to might. Okay. I don't want to, I think it might work when it comes to cleaning out my screens. I don't want to sit out there for 2 hours cleaning out my dang screens. And I think this product might do that. So until I'm convinced it would go through my screens cleanly, the product in the Sunnyland the liquid in the Sunnyland jug, I wouldn't use. And I think it's an example of the actual manufacturing of the liquids. Let's look at 7 minutes in.
Fertilizer is the, I want to cuss, man, but it's the chocolate pudding emoji, smiley face emoji. I mean, seriously, it works. And when I put this stuff down, man, it got thicker, it got greener, faster than the other side. And like I said, I sprayed it, and I actually sprayed it at a lower rate. I didn't go to rate that they recommended.
Okay, so this liquid here on the left, I don't know if that's what he actually poured out of the jug or not. I didn't see him pour it out of the jug, but I'm assuming he's an honest man. He poured it out of the jug into this bottle, and that's what it looks like. You'll see a lot of liquid products that are very clean and clear like this in turfgrass management and turf products. You'll see this very frequently. And those are products that, I have confidence in will go through my screens, to be frank. Okay. That's what I'm really more concerned about. How can I get it out safely with the least amount of effort? And anybody who's stopped and cleaned out those dang spray nozzles and screens knows exactly the headache that you deal with when you make one little mistake. Something salts out or it's cold. Everything worked good in July, and all of a sudden now it's October and it's colder and everything salts out and you didn't know it. And you got problems. Now I'm going to skip ahead to what the other product looks like, the Sunnyland product looks like in the jug.
Let me show you the product that I'm talking about. It's the Sunnyland. All right, and that's what the liquid looks like. Like I said, it's kind of a brownish. Well, actually, I'm not gonna lie to you. This is shook up. This is shook up, so it's not exactly this color.
Yeah, so I mean, there's nothing wrong with yellow. I mean, pendimethalin's yellow and goes out no problem. But I just don't know. He was saying there's some stuff settled out in the bottom. He shook it up. I just wouldn't have a lot of confidence. I wouldn't even put that through my screen, honestly. I wouldn't say, well, let's test it. I'm just having the manufacturer, the distributor, you test it. You get your spray rig and show me it goes through the same size screen that I got, and then I'll be okay with it. But until then, I don't even want to test that. And I don't think, like I said, I don't think there's much value in iron chelates in terms of the agronomic response. Like I said, in the soil, they're going to oxidize anyway. It's a very expensive way to do it. And on the leaf, you're going to get a response from iron sulfate anyway. So why spend the money? But if the chelate results in that nice, clean, clear product that he showed before compared to this product, then there could be value in it. That's where I think the value of iron chelates actually lies in turf management. Because you're going to see a response from applying it foliar. It's just going to be very expensive to do it. Okay. So thank you to, I don't know this guy's name, Bermuda Grass Central. I mean, I could have gone out and got these products and done it myself, but I'm like, hey, he did it. He did a good job. So I'll just give him a pat on the back and say thanks for putting out that video, so I didn't have to go do it. So good job on that one. But that's my take on iron chelates for the most part. I don't see the value in them unless it's actually in the manufacturing. Agronomically, it's questionable and hit and miss at most. You can see a response, but it's usually very, very expensive. Okay. Having said all that, let me go back through the chat and see if there's anything particularly interesting or that you really want me to cover. I don't know if you guys are just chatting to yourself or you wanted me to if you had any questions. Okay. Okay. I don't see anything. Let's see here. Looney asks, this was probably a while ago. I don't even know if it's on the screen anymore. How important is the pH of water during a liquid iron treatment? Soil pH is often mentioned, but I don't usually see much info about the water source. So I don't think I have any articles on that specific topic, Looney, but I will say that the pH of the water is immensely important, very important. The iron in solution can settle out and oxidize in the liquid in the container just as easily as it can. Well, not just as easily, but it can in the container before it even hits the surface of the leaf or the concrete or whatever you're spraying it. Okay. So yes, the pH of the solution can have an influence, but I'll be honest, I can't think of an article off the top of my head that I can pull up. So until otherwise, that's just my opinion, and I could be wrong. Okay. Good question. Chuck Benzing asks, is there a chelated iron response study with a wettable powder or other dissolved products, Foliar app versus a drench? I know there is on Exoras in South Florida. I don't know about Turfgrass, a wettable powder iron chelate for Turfgrass. I will say that the studies that have been published, and I guess those are the only ones that really count, to be frank, but I have done a lot of work that was not published with powder coated iron. So the iron itself was powder coated onto a granule. And I saw no difference at all. I'm going to have to take a little lozenge. I'm sorry, my throat's starting to go. But I can't think of anything off the top of my head that would say wettable powder versus foliar. I've done a lot of granulars and I've done a lot of foliars, but I don't think I've looked at that. No, sorry about that. I can't think of an article off the top of my head, but it's possible. Maybe I can find one. Eric Sand says, curious how sprayable iron sulfate would affect the pH of water. I can look that up, but I'm pretty sure it lowers the pH. Iron sulfate will actually lower the pH of your soil too with certain magnitudes. It does it in a very different way than ammonium sulfate does. But iron sulfate can lower your soil pH. Probably nothing of any consequence, but it can lower it. Probably does the same thing with water. Yes, I have a lot of good questions tonight. Ulysses Serpa. I hope I'm saying your name right, Ulysses. He says, I have a subscription on Amazon for the Anderson's Humichar, which can change humic and biochar. I hope you cover either one of those in 2024 so I can possibly save some more money and reduce junk. I will cover humic acid for sure. Biochar is another issue. Biochar is an immensely complex and variable topic. The type of wood, the length of pyrolysis, the particle size. There's all sorts. Biochar there's a lot going on with biochar. I'm not comfortable with that topic, to be honest. Humic acid is a different one. Humic acid will probably be a month on humic acid at some point. Yeah. There's a lot of good information on turf grasses on humic acid. I would say in general, both those topics of humic acids and biochar in general are greatly oversold. You have to keep in mind, it's not complicated. It's really not that complicated, guys. It's much more complicated to keep people employed and to keep your bills paid and to keep all the creditors happy and all this lights on. That's difficult. People management, leadership, that's difficult. The turf grass is not that challenging. Oftentimes marketing and manufacturers and distributors, they want to make it complicated, make it difficult to understand because they want to try to convince you that you need to buy their products. It's basic blocking and tackling, guys. Water, light, temperature. When it comes to soil, nitrogen is almost always needed. I mean, I'm not going to say always, and there's sod productions in Florida that don't apply any nitrogen. But almost always nitrogen is going to be needed to achieve some desired quality that is not existing at the moment. And then after that, after nitrogen, very little is usually needed. Occasionally, you might need a little phosphorus occasionally. Occasionally, very rarely, you might need to apply some foliar iron if you want a little pop in color or something. But all these other products and they're all trying to find a niche in the market to get their product, like humic coated urea. They're trying to find a niche in the market to kind of corner something because why? Urea is a commodity. No one makes any money on urea. It's bought and sold on the open market. So they're trying to find like a unique sales pitch or a unique product that is proprietary to them, that you can only get it from them. So they have something unique to sell. There's something different. That's not a commodity. That's how the game is played in turf grass. I was in sales for 6 years, guys. That's what salesmen want. They want a unique product that only they have, because they know you can buy urea from anybody. You can buy ammonium sulfate from anybody. It doesn't have to be just from them. So these ideas like humic acid and biochar and all these other things, I'm not going to say you won't ever see a positive response to them. Occasionally hit and miss here and there, you might find something. But don't get lost. Keep your eyes focused on the basics, the fundamentals of agronomy: water, light, temperature, pests. Those key foundational subjects and topics are what's going to win championships. If you have all that dialed in and you want to play with some humichar, you want to play with some humic acid, you want to play with all these other things, then that's your money. I'm not going to say don't do it. There's not a lot of evidence to support most of that stuff. But if you have things dialed in and you're good and tight with all the water and light and stuff, then who am I to say don't go test it? You go try it if you want to try it. You want to put a little icing on your cake, then it's not, I'm not here to say don't do it. But I would not do that before I have my agronomic program dialed in to the point where it's agronomically and economically as efficient as I can make it. Next one. I really, really like these questions. These are good, guys. Sorry if I missed anybody's question. I'm not intending to look over anything. Overall, will the best cool season lawn come from granular or liquid fert program? Mitch Bird. I'm going to answer this with about 5 minutes left on my throat before I can't speak anymore. Overall, will the best cool season lawn come from granular or liquid fertilizer program? I'm going to give you the basic pitch that I give a lot of people. Well, I don't care if it's warm season or cool season. Couldn't care less. When it comes to these elements, they should almost the least expensive. When I say the most efficient, I'm talking about the least expensive for the agronomic response. They're going to come from these. Going to come in these forms: nitrogen, phosphorus, and potassium should be in a granular form if you want the least expensive option. Okay. When I say least expensive, I don't mean cost per bag or cost per pound in. I'm talking about cost per response. Cost to get the response in the turf. NP and K should be in granular. You can apply NP and K as foliar if you want to, but it's going to be more expensive. You can get the same response. It's going to be a little bit more expensive. Pretty much besides that, everything else should be foliar if you're going to apply anything. So if you're going to apply iron, we've shown already in 2 articles, it should come as a foliar application. Manganese, magnesium, anything else, you're not really going to see much from it. I have documented a response to magnesium and manganese, but it's extremely rare. There's really not much benefit to applying anything other than NPK, iron, maybe, sulfur, maybe. Okay. But you want to know what the best program is? When my definition of best is the most efficient program for the turf response, and that you're going to get the least expense into the system and get the most return out of the system, is going to be granular NP and K, and pretty much everything else foliar. Mitch, you've asked like 4 or 5 questions over the last several weeks, and almost every one of them I'm very impressed with. Very good questions. Sorry. Harper Explorer says you spray iron sulfate, liquid urea. Thanks again. Great video. Yeah, you're welcome. Thanks for watching. But before I forget, if you haven't subscribed, hit subscribe, I guess. I'm supposed to tell people that. I don't know why. And then I guess hit the bell icon. I guess you're notified. I'm very ignorant when it comes to YouTube. I'm sorry. I'm just here to help, I guess. Yeah. Okay. So there's anything else? I don't see. Oh, how about Super TA says, how about silica? Would love to hear about it. I've been using Montana Grow Silica. The best literature review I can think of for silica was given by Dr. Beth Gertall at I think it was the GIS, or was it GIS, or was it I can't remember if it's GIS or the ASA meeting. And if you want to know about silica, you're asking the wrong person because I'm not an expert in silica. I don't know if she would claim to be an expert in silica, but she did do a literature review on silica that I found very compelling and very interesting. And the short skinny of that presentation was, there may be a benefit to applying silica, but you'd have to apply it at rates so astronomically high that it's nowhere near the rates that are recommended now. And it would be so expensive. It would be, cost prohibitive. So the amount of silica you're applying in some of these silica products is like a grain of sand in the ocean, and you need the ocean to make a response, basically. That's my understanding of silica. But understand that's coming from someone who is not a specialist in silica. Okay. I'll be happy to go over that at some point. I'll probably have to ask Dr. Gertall to come on and help me, because I'm not a specialist in silica. And there's only 5 or 10 papers on silica and turf. My grad student before I left University of Kentucky was working on silica, and she did some work on silica. I don't know what I was politely, shown the door. But she continued to work on silica, and I'll have to look up her results. I don't know what she's found, but Gardner Earth Guy says, I taught urban fert in Milton in 2019. I don't think so. In 2019, maybe. I would go up to Milton occasionally on extension events, and we had an extension things going on. I think it was before 2019 that I stopped doing that. But if you have, I mean, maybe it's possible. I don't really remember. But I've been in Milton many, many times and given many talks, but I don't think I did in 2019. I could be wrong. All right, guys, that's all I got. I got a band closing this out tonight. I really appreciate everyone for showing up. I'll be back tomorrow morning at 10 a.m. Great show. I really appreciate all the questions, and I really appreciate your interest in this topic. We'll see how far it goes, but I really appreciate it. Like I said, I'll be back tomorrow at 10 a.m. Until then, thanks. Be kind. Have a good evening. Bye.